Introduction to Cartesian coordinate. So to understand Cartesian coordinate, we need to start with number line because that's where things start. I have a person whom I to give some instructions. So that place, I'll call it as 1. I want him to go near the tree. I'll tell him you need to go 3, not steps, 3 meters front of you, right? So he moves 3 meters front of him and he finds the tree. If I wanted him to go the other way around, I will tell go 3 steps back. So back here is negative. On a number line, back is taken as negative and forward is taken as positive. I'm sure most of you know this. Now, the extension of this idea is Cartesian coordinate, wherein you can see over here, it's a combination of 2 number lines with center as the 0 and right is your 1, 2, 3, 4, left is your minus 1, 2, 3, 4, up is your 1, 2, 3, 4, and down is your negative values. So it's been arranged. So we can tell that a number line is used when we are talking about straight line motion. So if you have a toy which just moves forward and backward, I don't know how popular it is now, but there used to be a time that was the cheapest toy, remote control toy. There used to be a wire attached to it, to the car directly, and we just had one thing going forward and backward. Don't ask me how that was enjoyed, how could someone enjoy that, but that's how it was. So then of course that time also there were this as well, the cars which could move 2-dimensionally, that is left and right. They could take turns. So to talk about taking turns, if we want to talk about a person walking on a plane or an ant moving on a surface or this very thing which I'm writing on, this uses Cartesian coordinate. Like literally, the basic idea of this, whatever this digital pad is, I have a digital pen. So if I move it across, the pad senses the coordinate, right? Whatever you're going to study now in this chapter, it senses where it is exactly, and it sends that information to the system, and system in turn interprets it with the help of the digital software, whatever I'm using, supporting software, and that's how the communication happens, right? So we can tell Cartesian coordinate is used to pinpoint where on a 2-dimensional plane are we talking about. So the language of instruction when we're talking about Cartesian coordinate is how far along do we have to move, you know. So here it was just left and right. Here it is about how far along. Along means left and right, and also up and down. Okay. So let's here I have a small game. Okay. So for myself, I guess, because you guys can't do it. So what is here? The thing is, this person has to remove whatever the item is in the chest and go to the finish line or finish point in this case. So what if this chest, the key is over here, and whoever does it fast will win. So what you can do is you can give him the instruction, you can pause it and think about the instructions that you can give him. You can just tell him about, give him a number and talk to him about going left and right, okay, or up and down. Only these 4 words along with the number is what we can use. So if you had to do so, what is the best way to do it? So you can pause and think about it. So first thing is to go to the finish line, we need the item. To open this chest, we need a key. And how can we go to the key? Well, we can be smart and we can use the vehicle. So first instruction is I'll make him go to the vehicle. So I'll always give the left and right instruction first and up and down. So I'll tell him go. Again, I can't use the word go. And I'll tell 3 right, 2 down. And the person comes back because I can give him instruction from this point only. That's why it's called as the origin. So he or she has to come back. And with the new speed that he or she has acquired, I'll give the next instruction 5 right, 4 up. And the person will search over here. It's a pile of mud. So in that we have a key. He or she will search and come back. And then I'll give an instruction of 1, 2, 3, 4, 5, 6. 6 left and 1, 2, 3, 4. 4 up. The person will go open the thing and come back. Then again I'll tell go 1, 2, 3, 4. 4 step to the left and 1, 2, 3, 4. 4 down. So this is your basic instruction and the person is able to do it. Okay. So if you think about it, the up and down words are not that I mean, it's not very feasible to answer such scenarios, right? We have to give information. That is, if you're moving left and right, it has to be, a better way, a smarter way to give this information. So what did we do? We saw a number line. A number line is just a single line wherein we have positive and negative numbers and decimals and whatever you want, all the numbers are there. And if you want to give a specific information about the distance the person has to travel, so you can do so by telling left and right. But if they want to move along a plane, we have to give up and down information also. So if you're talking about left and right, it is x-axis, and if you're talking about up and down, it is y-axis. So we're talking about vertical, and x-axis is horizontal. Okay. So again, up and down is horizontal. Left and right is horizontal. Up and down is vertical. So one more name for all of this simple name is x-axis. When someone tells x-axis, they're talking about left and right. If someone tells y-axis, they're talking about vertical, if not up and down motion. This is something that you need to remember. Okay. Now, I am not very convinced of the way I gave an instruction. This is not the best way. We can come up with a better way. And that's where our coordinates, if not order pair, comes into picture. So if I just tell 3, 2, instead of using the word up and down, if I just tell 3, 2, the person will immediately get to know that when I tell 3, I'm talking about left or right. When I tell 2, up or down. But you can ask, sir, how will we decide if it's up and down or left and right? We understand that, this has to do with horizontal and this has to do with vertical, but how left and right? And how up and down? If there is positive, it is right. And if there is positive over here, it is up. So basically it is right and up. And if you have to go left, it is negative. And if you have to go down, it is negative. Okay. So let me show it with this example. So here the person first went 3 right and 2 down. So this is 3 plus 3 minus 2. So if I just give this in, if I just scream out loud, plus 3 minus 2, the person will run over there and come back. And next instruction will be scream out loud, plus 5 plus 4. The person will know 5 steps to the right and 4 steps up. If I tell here 6 steps to the left and 4 steps up, instead of that, if I call out minus 6 and plus 4, the person will know they have to move to the left and then up 6 and 4 steps respectively. And here it is, the finish line is minus 4 and minus 4. Left and down, 4 steps and 4 steps respectively. Right? So we have a bit more, one more name that we need to know, coordinates. Coordinate is nothing but the space are called as coordinates. Chord is 1/4, is it not? So in a 2-dimensional space, we have 1/4, each region is 1/4 of the entire space. That's why it's called as coordinates. So there are 4 coordinates. 1, it always starts over here. Second is this, third is this, and fourth is this. It goes in anti-clockwise direction. And this is fixed. You can't change it. In the first coordinate, since it's right and up, it is always positive and positive. In second coordinate, since it's always left and up, negative and positive. Since it's left and down, the third coordinate, it's negative and negative. Fourth coordinate is, since we're talking about right and down, is positive and negative. Okay. And the center is called as the origin. So this is something that we need to know. And one more thing, the lines are not, they don't belong to any coordinate. The lines does not belong to any coordinate. This have their respective name, x-axis and y-axis. Their axes, and they divide the region into 4 different coordinates. They themselves are not part of any coordinate. So to summarize, Cartesian coordinate are extension of number line idea, which helps us talk about movement along a two-dimensional plane. The uses are a lot, and the names, there are certain names that we need to know, starting from the origin, which is the center, and the x-axis, which talks about left and right, and the y-axis, which talks about up and down. If you want to give the best possible information locating a point on the axis, you can do it so with order pair, if not coordinates. So always the x-axis is called as, okay, this is something which I missed, abscissa, and y-axis, component of the number is called as ordinate. This is again something which you need to memorize. So this is always x and this is y, another name for x and y component. Okay, again, just have it in your head. A is x and O is y, right? So don't worry, they won't ask what is x-axis called as and y-axis called as, or x component of the order pair is called as. They won't ask you that, but they'll give you information related to that. And we saw 4 regions, right? The 4 coordinates, the 4 quadrants, sorry, which the axis divides the graph to.